Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 23, the last lesson in module 2, solving equations using algebra. Classwork exercise 1, youth group trip. The youth group is going on a trip to an amusement park in another part of the state. The trip costs each group member $150. There's a key right there, which includes $85 for the hotel and 2 one-day combination entrance and meal passes. So that's the hotel 2-day stay, $85 for the hotel, and 2 one-day combination entrance and meal plan passes. So they go into the park 2 days with food. Write an equation representing the cost of the trip. Let P be the cost of the park pass. So P, cost of park pass, would equal, well, actually I already said that, so I don't have to write it. I would say P equals the cost of the park pass, but it's already right there. Write an equation representing the cost of the trip. Well, the cost of the trip is each group member pays $150. So I know that the cost of the trip is $150. And that includes $85 for the hotel plus 2 one-day passes. Cost of the park pass, 2 one-day combination entrances. So there's the equation. Or if I wanted to rewrite this in standard form, it'd be 2p plus 85 equals 150. Part B says solve the equation algebraically to find the cost of the park pass, then write the reason that justifies each step to the statement. So let me just bring this over here. There's our original. Okay, so then what I'm going to do is subtract 85 from both sides. I'm trying to isolate the variable p. So this would be 5 and 14, that would be $65. 2p. So 85 minus on both sides, that's the subtraction property of equality. What you do to one side, you do to the other. I subtract 85 from the left, I have to do it to the right. Okay, but if we want to get technical, we could say plus 0. 85 minus 85 is 0, and then that would simply be 2p equals 65. And that's the additive identity. Anything plus 0 is itself. Okay, so if 2p equals 65, then if I divide both sides, then I get p equals 32.5. So I'm just going to do this. And put this here. Bear with me, I'm just trying to save some writing. This is the division property of equality, or the multiplicative inverse multiplication property of equality. Okay, multiplicative property of equality. I multiplied both sides by 1/2, if you will. Okay, so then p equals 32.5. That's the multiplicative identity because it'd be 1p equals 32. So that's just simply p equals 32.50 since it's money. And that is the multiplicative identity. So the park pass costs $32.50 per day with food, which isn't bad. Okay, now it says to model the problem using a tape diagram and check your work. So what I'm going to do is I'm just going to use a shape for my tape diagram. And if I have a tape, let's say it's that long, that whole thing represents $150. Let me move this down a little so I can write. Okay, so this whole thing is $150. And then if I take and separate this out like this, then this portion here would be the $85 hotel. And then I would have to split this again like so. And then I might want to move this over because these are not equal to 85. Let's move that. Maybe over like that. And let's try to move these so that they're equal. Okay, something like that. There we go. That's better. Actually, that should be moved over here a little bit more. Make those two equal because those are equivalent, $32.50. That would be the park pass. So we knew this was $85. So to solve this, we would say 150 minus 85 would be 65. So if this is 85, this is 65. And then you divide the two, and we get 32.50. Okay, so that's what a tape diagram would look like for your trip. All right, next one. Suppose you want to buy your favorite ice cream bar while at the amusement park and it costs $2.89. If you purchase the ice cream bar and 3 bottles of water and pay with a $10 bill and receive no change, then how much did each water bottle cost? So it's going to be the ice cream plus the water, and there are 3 waters, so let me say 3W equals $10. And I know the ice cream is $2.89. So plus 3W equals $10. Okay, so I substituted in my givens. Then I'm going to subtract 2.89 from both sides. And that is going to give me 3W equals $7.11. Okay, so all it wanted up here was the equation, so I just fixed this up a little bit. So here's my equation. 289 plus 3W equals 10. Write an equation. But then it says solve the equation to determine and write the reasons and justify. So this is the subtraction property of equality again. So let's just do this. So this is the subtraction property of equality. Subtract both same amount from both sides. And then if I multiply both sides by 1/3, these cancel and I get 1W. The 3's cancel and I get 1W equals 711 divided by 3. Okay, so let's do that. 3 goes into 7 2 times with a remainder of 1. 3 goes into 11 3 times with a remainder of 2. And 3 goes into 21 7 times. So the water is $2.37 each. So therefore W equals 2.37. So let's just type this just to save. It's hard to read anyway. Okay, so multiplying both sides by 1/3 is the... Okay, so subtraction property of equality was this, but if I actually put this in here, let's just do it. This would be 289 minus 289 is 0 plus, and that would be the additive identity. Okay. Then after that, then I would get the multiplication property of equality is multiplying both sides by 1/3, and then we get 1w equals 2.37, and that is the same as just saying w, because 1 times w is the multiplicative identity, giving us w. Okay, now it says to model the problem using a tape diagram to check your work. Okay, so we're going to use a tape diagram. And if I draw the tape diagram like so, and then I draw segments in between, I know that the ice cream was one price, and then I'd have split this up into 3 equal pieces. Okay, so then I need to label this. This is the $2.89 ice cream. And then this is a water, and this is a water, and this is a water. The total is $10. And there's our tape diagram. So if I did it this way, then I'd say, well, 10 minus 2.89 is 7.11, and there's 3 waters, so this represents $7.11, and you divide it by 3, and that gives us 2.37. So each one of these is 237, 237, 237. Number 2, weekly allowance. Charlotte receives a weekly allowance from her parents. She spent half of this week's allowance at the movies, but earned an additional $4 for performing extra chores. If she did not spend any additional money and finished the week with $12, what is Charlotte's weekly allowance? Write an equation that can be used to find the original amount of Charlotte's weekly allowance, and let A be the value of Charlotte's original weekly allowance. Okay, so there's our variable, and it says if she did not spend any additional money and finish the week with $12, what's her weekly allowance? So if I want an equation, I know that it's going to equal 12 because that's how much money she had at the end of the week. She made an additional $4 for doing extra chores, so that $4 is a constant. She spent half of this week's allowance that we don't know the value, and A is her allowance, so that would be 1/2 A. So half of her weekly allowance, then she made $4, and then she ended up with 12. So now it says to solve the equation to find the original amount and write each reason. So I'm going to write 1/2 A plus 4 equals 12. So I'm going to subtract 4 from both sides. So minus 4, and I'm going to get 1/2 A plus 0 equals 8. I'm going to show all my work this time, and this is the additive or subtraction property of equality, I mean. Okay, the subtraction property of equality means that if you subtract 4 from the left, you have to do it to the right, and the values are still going to be equal. So then once I get this, I have 1/2 A plus 0 equals 8. So if I have this, then I'm going to get 1/2 A equals 8, because anything plus 0 is the additive identity. I can't just put identity because there's a multiplicative. Additive identity. Okay, and then I'm going to multiply both sides by 2, and 2 times 1/2 is 1A. 1A. I don't want to write my 1 like that. 1 times A equals 16. So this is the multiplicative identity. I'm sorry, multiplication property of equality. Okay. And then 1 times A is simply A equals 16, and that is the multiplicative identity. Because we multiplied both sides by, or 1 times anything is that anything. So her original allowance was $16. Okay, so explain your answer in the context of the problem. Charlotte's weekly allowance. Explain your answer in the context of the problem. Charlotte. Here, let me just do this. Charlotte's weekly allowance is $16. Okay, part D says Charlotte's goal is to save $100 for her beach trip at the end of the summer. Use the amount of weekly allowance you found in part C to write an equation to determine the number of weeks that Charlotte must work to meet her goal. Let W represent the number of weeks. Okay, so how much money does she want? That is our total. So it's got to equal $100. And she makes $16 in an allowance per week, and that equals 100. So there's our equation, 16W. And looking at your, and then what does it say? Use the amount of weekly allowance you found in part C to write an equation. Did that. To determine the number of weeks she must work to meet her goal, let W represent the number of weeks. Okay, so if we do the multiplicative, or multiplication property of equality would mean multiply both sides by 1 over 16, which is the same as dividing by 16. And that'd give me 1W, which is simply W. And then 100 divided by 16. Okay, so I got my calculator. 100 divided by 16, enter 6.25 weeks. Okay, a quarter of a week. Well, what's a quarter of 7 days? It'd be so many hours in a certain day of the week. And so in looking at your answer in part D, it says, and based on the story above, do you think it will take Charlotte that many weeks to meet her goal? Why or why not? Okay, so Charlotte needs more than 6 weeks allowance, so she will need to save 7 weeks allowance and not spend any of it. There are 10 to 12 weeks in the summer, so yes, she would be able to do it as long as she doesn't spend any money. Number 3, travel baseball team. All right, Alan is very excited about joining a travel baseball team for the fall season. He wants to determine how much money he should save to pay for the expenses related to his new team. Players are required to pay for uniforms, travel expenses, and meals. If Alan buys four uniform shirts at one time, he gets a $10 discount. So the total cost of four shirts would be $44. Write an algebraic equation that represents a regular price of one shirt. Solve the equation. Write the reason that justifies each step using if-then statements. Okay, so first of all, we want to let a variable equal something. So let S be the cost of one shirt. Okay, S is the cost of one shirt. Okay, they said to use if-then statements, and they probably said it earlier and I didn't, so I would say if, and then we need an equation. Four uniform shirts at a $10 discount. So if he buys four shirts and then they subtract $10 off of that order, then it would cost him $44. So there's our equation. So if 4s minus 10 equals 44, then if I add 10 to both sides, that would be 4s minus 0 equals, let's say plus 0, equals $54. And that's the addition property of equality. Okay, so if 4s minus 10 is 44, then 4s plus 0 equals 54. Okay, if, and this is my if 4s plus 0 equals 54, then 4s equals 54. And that's additive identity. Okay. Then I'm going to say if 4s divided by 4 equals 54 divided by 4, then 1s equals 13.5. No, I don't want to do that. Okay, I know this is tedious, but if you learn your properties, it's really helpful. I want to repeat this. If 4s equals 54, then 4s over 4 equals 54 over 4. And that is the multiplicative property of equality. Okay. And I'm not going to say this again, but it would, then I would say if 4s over 4 equals 54, then, that's an s by the way, not 15, then 1 times s equals 1350. And then I'd say if 1s equals 1350, then s equals 1350. And that is a multiplicative identity. Okay. And therefore the cost of one shirt is $13.50. And yes, you should write a complete sentence. So you should say the cost of one shirt without a discount is $13.50. What is the cost of one shirt with a discount? Well, that was 4s equals 44. And if I divide both sides by 4, then s equals $11. Okay. D says, how much more do you pay for a shirt if you buy them one at a time than rather in bulk? Well, then you would say $13.50 minus 11, and the difference is $2.50. So you'd pay $2.50 more if you didn't buy 4 at a time. Alan's team was also required to buy 2 pairs of uniform pants and 2 baseball caps, which total $68. A pair of pants cost $12 more than the caps. Write an equation that models this situation. So you're buying 2 of each, so you can break this out. So 2 uh, pants plus caps equals $68. Okay? So for starters, we're just going to say 2 pair of pants plus baseball caps equals $68. But then it says a pair of pants costs $12 more than a baseball cap. So P equals a cap plus 12. So now I can substitute that in for P. So now I can say 2, and instead of this P, I can replace it with C plus 12. And then plus this C, and that equals 68. Okay? And then I can rearrange this, and that is 2 times 2C plus 12 equals 68. Okay? And then I can take that even further and distribute the 2 and say 4C plus 24 equals 68. So any one of these equations would represent the cost of the baseball cap, any one of these 3. Part F says, solve the equation algebraically to find the cost of a baseball cap. Write the reason that justifies each step using if-then statements. Okay, I'm not going to do that again just for the sake of time in the video. I'm just going to continue and solve, and I'll say it, I won't write it. So the first thing I'm going to do is I'm trying to use this equation here. And all I'm going to do is subtract 24 from both sides. So that is the addition property of equality. I added a negative 24 to both sides. That would leave me with 4C plus 0 equals 68. And then 4C plus 0 is 4C. That's the additive identity. And then the multiplication property of equality, I could multiply both sides by a quarter. Multiplying by a quarter is the same as dividing by 4. And that would leave me with 1C equals 60. Not 68. 1C equals 68 divided by 4, which is 1/7. Okay, so then I would say, well, 1C is C because that is the multiplicative identity. So a cap is $17. Okay, and I made a mistake here. I was talking and wasn't thinking at the same time. I guess I can't talk and think at the same time. So if I subtract 24 from 68, I don't get 68. 8 minus 4. Ay caramba. 8 minus 4 is 4. 6 minus 2 is 4. So then I have 44 divided by 4, and that is not 17. That is 11. So 1C equals 11, therefore C equals $11. So one baseball cap equals $11. Now it says to model the problem using a tape diagram. Okay, so I draw a tape diagram. What would that look like? It would have, how many ball caps are we buying? 4. 4 baseball caps, 2 pair of pants. Okay, so just real quick, if I do this and I break it up into groups, okay, so there's 3, I want 6. 1, 2, 3, 4, 5, 6. And we probably do want to have them somewhat evenly separated. And that should go this way a little, and this one this way a little more, maybe even a little more. Try to make them equal. And I have 7, so then I will erase this. Oh, I can't. Oh, that's too bad. Okay. Well, let's do this. Let's delete that and make these even. 1, 2, 3, 4, 5, 6. All right, so make them bigger. Okay, something like that. So what do these represent? Well, the whole thing is 68 bucks. And this is a cap, 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 and this is a what? If I go back, it says a pair of pants costs $12 more than a baseball cap. And we're buying 2 baseball caps. So this is a cap, and this is a cap. And this is a cap plus 12. So that's the cap plus 12. That's a pair of pants. And this is a cap, and this is 12. So that'd be a pair of pants. Pants are $12 more than caps. Okay. So you have 4C plus 12 times 2, which is 24. And that's what we started with up here, 4C plus 24. What is the cost of 1 cap? And that's when you would write, this is 68 minus 24. So you take the numbers first. You take 68 minus this 12 plus 12, or 24, and you get 44. And then you divide that by the 4 C's, and C is 11. So the cost of 1 cap is $11. What is the cost of 1 pair of pants? That is $11 plus the $12. $12 more than a cap, so $23 for a pair of pants. Okay, that is the end of lesson 23. Review the lesson summary and go do your problem set.